Welcome to part 5. Now that the MOSFET has been arranged, let us quickly make the transformer, then we can come back and continue with the MOSFETs.
Hello guys, I think I mentioned, I highlighted some of the components of the inverter, and right before us they are the components needed to make a transformer. So I'm about to make the transformer, and I'm going to need this for the high voltage low current side, and I'm going to be using this for the low voltage high current side. You might be wondering what these are. These are copper wires, and you can get them from a winder's shop. People who rewind your generator, people who rewind your pumping machine, so you should be able to get this from them. So this is copper. I think this gauge, they call it this gauge number 19, and this gauge number 8. So what I'm trying to do is to show you, these are frames to hold the coils. The coils will actually be on these frames. I'm showing you the two types of frames for the winding. This one has separated spaces. This is where the high voltage will be, and this is where the low voltage will be. That is, these ones will be used here, and these other ones will be used at this point. So there's no major difference between the two. I just like to do things in different ways. If I'm going to use this one, firstly, I'm going to wind this on it. I'll wind it around here. When I'm done with it, I'll wind this on top of this. It will be on top of each other, but for this type, they're going to be separated. They won't be on top of each other. So basically, to me, they give the same result. But don't worry anyway, you can actually get the transformer. You can buy it. If you can't go through the stress or learning the process of making a transformer, you can actually buy it. I'm going to wind about 300 of this, 300 tons for this, and I'm going to wind about 12 tons for this. So this is the low voltage high current coil, and this is the high voltage low current coil. So if you can't make the transformer by yourself, it's something you can walk into the market. Is available in the market. Just tell them the specification that you want. Okay, I want a transformer of so specification. And inverter transformers are very common. They are very common. So, but I don't want to go through the details of how to make a transformer, but I just want to show you how it's being made. You can go through the details if you like equations and mathematics. Everything is being calculated anyway. But if you can't go through those processes, you can just bypass it by buying a transformer. And I think sometimes it is cheaper to buy, but for somebody like me, I'm used to experimenting, trying to figure things out. That's why I'm going to try and make the transformer. Thank you. Hello guys, um, good morning. This is the MOSFET that we worked on. They have been connected to a board. I placed a board underneath. All these stuff you're seeing, they are just about mounting and assembly. They are not really electronics or something. So this is the heat sink that we made. I've connected a board, and this is a bolt and nut, and there is another aluminum frame here. My intention is to have the setup in the inverter like this. When this is in operation, it normally heats up, it normally radiates heat. So to cool it down, I'm going to have a cooling fan positioned next to it. So this is the plan. There's a cooling fan that will blow whenever. There'll be a temperature sensor attached to this heat sink, so whenever it gets to a preset temperature, the fan starts to cool it down. The fan has two speeds. When it is slightly hot, the fan comes up with half of its speed. When it is getting really hot, the fan goes to full throttle. It goes to full speed until the temperature drops. So as you can see, I told us about this platform on my transformer. I told us about this. My intention is to have this setup move and stay on this. So this is how the setup will look like in the inverter. I hope you understand why we created this platform. This will hold the MOSFET so that we can have this point connected to the MOSFET. The transformer will be connected to the MOSFET, and the cooling fan is directly here. So that's the reason for all the support. So I think we are getting there gradually. Alright guys, welcome once again. This is the H bridge. I have a capacitor attached to it. Normally H bridge for inverter uses capacitor bank. That's why I fix a capacitor into this area. And I just want to explain some electronics of the H bridge. I've configured this H bridge such that DC voltage will come in through this place. DC voltage will come in here. This is where positive will come in, and this is where negative will come in. This is negative, and this is where positive will come in. So, and this is where AC will come out. When we connect battery to this end, DC comes in from the battery, then AC comes out of this place. If you connect 12 volt DC, we'll have 12 volt AC here, but it will not do that automatically. There needs to be some signals to activate the bridge. So I've made provision for that. These connections, these are the point where the signals will come in. Those signals are responsible for turning on and off the H bridge switches. So that's what the signal will do. The signal will come from the MOSFET driver board. So I just want us to see that place. This is the H bridge. This is the signal input to the H bridge, and this is the power input to the H bridge. DC power comes in, then AC power comes out. So as we know, transformer works with AC. That's why this is the point that will be connected to the transformer. Something like this. Let me show you. This is how I'm going to connect it. So So I'm going to put both a knot around here to bolt it down. So AC flows into the transformer. Transformer wants to get AC, but DC comes in to the H bridge. So as you can see, if I may name this configuration, I will call it T bridge, but on the diagram on the electronics it is called H bridge. But the way I've configured mine, the circuit diagram will not tell you how to configure it in real life. So what you need to do is to configure it in any convenient way, and I've told us that I will show us some other configuration of H bridge. So in this case, I've configured mine to look like something like a T. So let's just call this one T bridge. H bridge configured in T bridge. So DC comes in, plus from the battery, minus from the battery, then AC comes out. Thank you.
To be continued in part 6.